So this is the digital notebook that I'm sharing with you on bonding units. And the outline that we'll have for this unit is that on lesson 1, we will see and discuss what is the Lewis dot diagram for ionic compound. And then we'll move to the molecular compound, and then we'll go further into structural diagram and the electronegativity, VSEPR, dipole theory, and boiling point and properties of solids. You have this posted on your or shared with you on Google Classroom. So we'll start with the first lesson, which is the drawing the Lewis dot diagram of an atom, drawing the Lewis dot diagram for ions, and drawing the Lewis dot diagram for ionic compound. Now, remember that the Lewis dot diagram, which very often is known as the electron dot diagram. And very often what you will see for Lewis dot diagram will be LDD, and for electron dot diagram will be EDD as the acronym for that, is representing the number of valence electrons in the atom. So we don't care pretty much what is happening with the electrons in the outer shell, but we just worry about the electrons in the outer shell. Valence electrons are found on the outer shell of the element. So when we are having elements of group 1, and here I'm talking elements like lithium, sodium, potassium, and so on, the valence electron is 1. And when we see the group 2, which are elements like beryllium, magnesium, calcium, strontium, barium, and so on, the valence electron is 2, and so on. So then you skip all those that depth that is on the periodic table, and then you start on group 18. Group 18 has 8 valence electrons in the outer shell. Group 17 has 7 valence electrons. Group 16 has 6 valence electrons. Group 15 has 5 valence electrons. Group 14 has 4, and group 13 has 3 valence electrons. So we will focus, when we are drawing the Lewis dot diagram, we will focus on those electrons that are in the outer shell, not what is happening in the inner shell. And that whatever is in the inner shell is not taken into consideration because it is considered to be a completed one. The electrons in the Lewis dot diagram or electron dot diagram are represented by dots. And they are drawn around the symbol of the element. So when you see a Lewis dot diagram, you will see something like this being the symbol of the element. And then we will start drawing the Lewis dot diagram as dots that are around the symbol of the element. And when we are drawing those dots, we may start anywhere, it doesn't really matter, but as the rule that we have been doing here in chemistry is that we start from up, from the top of, so if this is the symbol, then we start drawing the electrons from the top to the left, down, to the right, and then we keep moving until all the valence of the electrons is drawn. So if there are 6, then we'll draw 6. If there are 7, then we'll draw 7 dots. Each direction is known as a domain, and each direction can carry maximum 2 electrons. So you cannot draw more than 2 electrons on Lewis dot diagram. So let's start by drawing the Lewis dot diagram of those elements. So the first one is hydrogen. Hydrogen has 1 electron in the valence electron. So we just draw it with 1 electron in the valence electron. Beryllium has 2. So, and how do we know that it has 2? Because it is on group 2. Fluorine on the other side has 7. So we'll start with 1, 2, 3, 4, 5, 6, 7. Helium, which is on the second place of the periodic table, has 2 electrons. So helium is an exception. And we will draw those 2 electrons here because helium has only 1 energy level, and on that energy level, the maximum that it can carry is 2. And then we have lithium, which has 1 electron in the outer shell. And then we move to sodium, which as well has only 1 electron in the outer shell. And then oxygen has 6. So the way that we draw them is 1, 2, 3, 4, 5, 6. And then chlorine has 7. We know because it's on the 17th group. So 1, 2, 3, 4, 5, 6, and 7. Right? As you see here, on some of the elements, we saw that we had 1 or 2 electrons in the outer shell, or when we draw the Lewis dot diagram. Those electrons that are paired up, those electrons that are paired up, so you cannot add more than 2 electrons on each domain. So those electrons are known as the lone pairs. Electrons, in a difference with the bonding electron that are single. So lone pair electrons are the electrons that are paired up with another electron, while bonding electron are the electrons that are singled. So now, the group of the elements in the periodic table determine the number of valence. For example, beryllium, which is in group 2, has 2 valence electrons. Oxygen, which is on group 16, has 6 electrons. And helium, that is on group 18, has 2 valence electrons. And because this is an exception, helium is on the first period, which has only one energy level. However, for the other noble gases like neon, argon, or so on, the number of valence electrons is 8. Okay, so now let's see how can we draw. This is kind of a review from Science 10. So here you will draw the valence electron for helium, lithium, beryllium, and then this was hydrogen. Helium is here, neon is here, and then we'll go fluorine, oxygen, nitrogen, carbon, and boron. Okay, so I'll stop here, and then you can draw the Lewis dot diagram for this, and I will do it in class. Now let's take a look onto how to draw the Lewis dot diagram for ions. Just to refresh your memory, ionization is the process where the electrons are lost, losing, or gaining electrons to achieve a full valence shell or outer shell. During this process, what is happening? Electrons are metals are giving the electrons, and on this case, they are becoming positively charged because the number of protons is greater than the number of electrons, and non-metals are receiving the electrons, and so they are becoming negatively charged. And what is happening during the ionic compound, the formation of the ionic compound, what is happening? They are attracted together, since they are two entities with opposite charges. So metals form a positive ion, which are also known as cation. By losing electrons, and non-metals are forming negative ions, which are known in other words as anion. By gaining the electrons. So one has to lose and the other one has to gain. When we draw the Lewis dot diagram for ions, they are shown in square brackets. So when we draw an element like we drew before, we just draw the elements, but when we are working with ions to show that we have ions, so then we use the square brackets. So atoms, sodium atom when we are drawing the Lewis dot diagram, does not use square brackets, and the Lewis dot does not. Use square brackets, and the Lewis dot diagram for sodium will be sodium, since it is on the first group, will be only one electron in the outer shell. What do we have in the sodium ion? We will use square brackets, and the Lewis dot diagram for it will be just like this. And it's so now ion is +1. Okay, so let's see now how can we draw the Lewis dot diagram for the following ions. So magnesium is on group 2. So then the Lewis dot diagram for magnesium ion will be the symbol, which is Mg, and since it is on the second one, we'll be losing 2. And aluminum will be losing 3, so aluminum will be 3+, while oxide, it has, so if we are drawing oxygen as the atom, then it's on the 6th one. 1, 2, 3, 4, 5, 6. This will be atom, okay? The Lewis dot diagram for the atom. But now what is happening, there are 2 more electrons that are coming here in the outer shell from somewhere else, maybe magnesium, maybe aluminum, who knows, from others. So now this is becoming an oxide, okay, by adding those 2 electrons here. So therefore, the Lewis dot diagram for this case will be the symbol, and then what we are telling here is we are showing that the Lewis valence shell is completed, so will be 2-. And for bromine, which is on the 7th place, if we have an atom, so bromine will be 1, 2, 3, 4, 5, 6, 7. However, when it is becoming ion, what is happening, 1 electron is headed toward that, completing the outer shell. So this is ion, and the Lewis dot diagram for ion, we will use square brackets to show that we are dealing with an ion, and will be with a full valence shell completed, and this will be -1. Notice that metals loses the electron, lose electrons, and they have an empty valence, and this is why we do not draw any dots for the Lewis dot diagram here to show that the valence is completed. And non-metals gain the electrons, and they have a full valence shell. They have a completed valence shell. This is why for metals we don't draw any, because what do we carry about the Lewis dot diagram or electron dot diagram is just the outer shell. And now let's see how can we draw the Lewis dot diagram for ionic compounds. Let's recall here what ionic compounds are. What is happening during the ionic compound is that one metal is combined with a non-metal. So now what do we see is that the metal has a tendency to lose the electrons that is in the outer shell to keep the valence shell completed or empty in this case. And then this electron that is lost by the metal is gained by the non-metal. And then what we have is we have again 2 entities, one that is positively charged and the other one that is negatively charged. And in between those 2 exists that is known as the electrostatic force, because 2 opposite charges will attract each other. And this is what is happening here. They will attract each other to form an ionic bond. So ionic compounds are formed when there is an exchange of electrons. One is losing, the other one is gaining the electrons to form the ionic bond. And this force that exists between those two, it's relatively strong. So now, when we are writing the Lewis dot diagram for ionic compound, what do we have to keep in mind is that we write the chemical formula of the ionic compound, determine the charges, and then we use the coefficient. Remember that the coefficient of 1 in chemistry is invisible. So let's see, lithium fluoride. Lithium as an atom has 1 electron in the outer shell. Fluorine as an atom has 7 electrons in the outer shell. Okay, now what is happening here? Lithium loses this electron, and fluorine gains this electron here. And I will draw it with the red one so that it's completed. So now, in terms of lithium fluoride as the Lewis dot diagram, we will have lithium that doesn't have as an empty valence shell, and by doing so, what lithium is becoming a positively charged, so 1 plus, and then fluorine is receiving that electron, completing the outer shell with 8 electrons, because that is known as the octet rule. You remember that? We mentioned it even when we were doing the review of Science 10. And then the Lewis dot diagram for lithium fluoride will be like this. Now, as we mentioned here, those are 1 lithium and 1 fluoride, and they are, since the coefficient is 1, the coefficient of 1 in chemistry is invisible. Let's move to the next one, that is sodium fluoride. So when we see sodium as an atom, then we will see that sodium has 1 electron in the outer shell. However, when we take a look at the oxygen, oxygen has 6 electrons in the outer shell. So 1, 2, 3, 4, 5, 6. So now 1 electron of sodium is going to complete the electrons with another pair. Okay, so electron. However, we have another bonding electron here. So then what is happening, another sodium that has a valence of 1 again will give this electron of the outer shell to complete the outer shell or the valence shell of oxygen with 8. So then what does that mean is that we have 2 sodium here, 2 sodium ions, 2 sodium ions, with each of them with a charge of +1, and 1 oxygen with the valence shell completed, because now it took 1 electron from 1 sodium and the other one from the other sodium, and it has a charge of a -2. Let's see now aluminum oxide. So aluminum has a charge of +3. So, and oxide has a charge of 2. Okay. So when we draw the aluminum atom, then we will have aluminum 1, 2, 3. And what is happening here with oxide is 1, 2, 3, 4, 5, 6. Okay, so now let's see this process here. One electron of the aluminum is moving to complete the bonding electron of oxygen. Okay, the other electron of aluminum is going to complete the other bonding electron of the oxygen. Okay, good. We're good. So now, valence shell of the oxygen is completed here. However, we have an extra electron here for the aluminum. So then what will happen is a second oxygen, which has 6 electrons in the outer shell, will interfere and say, okay, I will take this electron and complete one of my bonding electrons with making it a lone pairs. And now this bonding electron that is here is saying, oh, I need another electron though. So then another aluminum that has 3 electrons is giving one of the electrons to complete the other bonding electron. But see what we have now. So we have oxygen, both oxygens have a valence shell completed, but we have 2 electrons of aluminum that are not completed. So a third oxygen that has 6 valence electrons here is saying, okay, I will take those 2 electrons, and on this way, what will happen is that all 3 oxygen has a completed valence, and all 2 aluminum have a completed valence. So when we write the ionic Lewis dot diagram for this ionic compound, we will write something like this. We have 2 aluminum ions, which each of them is +3, and then we'll have 3 oxygen, which have a valence shell completed with 2-. Now, one thing that you can see here in all of them that we have done the questions is that the net charge will be 0. So on the first case, +1 - 1, net charge is 0. On the second case, 2 times +1 + 2 - 2, charge 0. Net charge is 0. 3 times +2 is +6, and 3 times -2 is -6. So the charge is 0. Okay, so let's take a look now to magnesium oxide. So what do we have here for magnesium? I will erase this. So magnesium as an atom has 2 electrons in the outer shell, so 1 and 2. And oxygen as an atom will have 6, 1, 2, 3, 4, 5, and 6. So this is kind of easier than the previous example because one electron of magnesium will complete the bonding electron, making it a lone pairs, and the other one will go and complete the other bonding electron and make it a complete one. So the Lewis dot diagram for this particular ionic compound, since we have one of each, will be magnesium, which the valence electrons are not disappeared, but they are going to oxygen, and then oxygen that has now a valence shell completed with a charge R of -2. Okay, so this is now your turn to work on those questions, and we can do them together in class. After this, after we are completing them in class, you can work on assignment 1 and complete this, the whole thing here.